Welcome to qnawire.
We want to calculate what is going to be the value for delta G under the following conditions, in which we're going to have the different pressures of the gases that are part of the following reaction at a temperature of 25 degrees Celsius, which is going to be the same as 298 Kelvin. Well, 298.15 Kelvin, just to be extra accurate about it. So the delta G's of formations of the compounds that we're going to have are for NO gas 86.7 kilojoules, and for nitrosyl chloride I'm going to employ the value that was provided by you in your question, that is a delta G of formation of 66.1 kilojoules per mole. If you want, you can re-verify what are these values in order to get the correct answer. You can use the Alex data tables in order to get our result. So the delta G for a given reaction is going to be equal to delta G naught plus RT times the logarithm of the equilibrium constant. In this case, since we're out of equilibrium, it's going to be the logarithm of the quotient of concentrations. So we are going to require the value for delta G standard, which is going to be equal to 2 times the delta G of formation of nitrosyl chloride as a gas minus the delta G 2 times the delta G of formation of NO as a gas. Remember that the delta G of formation for Cl2 in gas phase is going to be equal to 0 because it's an element in its standard state. So what we're going to get is 66.1 times 2 minus 86.7 times 2, which gives us a delta G standard of minus 41.2 kilojoules per mole, of reaction. You can actually leave it as kilojoules if you want. Now, with the information for the pressures of the gases, we know that the quotient of concentrations of the quotient of pressures in this case is going to be equal to the pressure of NaCl squared divided by the pressure of NO squared times the pressure of Cl2. Remember that the quotient of concentrations or of pressures is going to have no units because those are going to be given in terms of activities. So the pressure of nitrosyl chloride is going to be 8.04 atmospheres. In this case squared, divided by the pressure of NO2, of NO, that is 0.962 squared. And the pressure of chlorine gas, which is 4.63 atmospheres. This is squared, 4.63 atmospheres. Let's just clean up a little bit here because the 2 of the square doesn't look extra nice. So the value is like this, and the value for Q is 15.086. 8624 if you want. In this case, we can calculate directly the logarithm of Q, which is going to give us 2.71378. So the delta G is going to be delta G naught, that was minus 41.2 kilojoules per mole, or kilojoules directly, plus the value for RT, which is going to be kilojoules per mole, 8.314 joules per mole Kelvin. As you may notice, the value for the gas constant is given in joules, while the delta G, we require it in kilojoules. So we need to add the conversion factor, that 1000 joules is equal to 1 kilojoule. And we can proceed with the multiplication of temperature, that was 298.15 Kelvin. Over here, we're going to multiply by the logarithm of Q, that is 2.71378. And the result that we get is a delta G for the reaction under these conditions of minus 34.47 kilojoules, which rounding up to the nearest kilojoule would be delta G equal to minus 34 kilojoules. And with that, it would be all. Thank you very much and have a good one.